Okay, today we are going to convert rates and measurement. We will spend a few class periods on this. Make sure that you have your calculator and the handouts given you in class, especially the handout that has this chart on it, the measurement conversions chart. This is from your textbook, but I just wanted to make sure that you had it handy with you. So let's go ahead and talk about this. What does it mean to convert rates? Well, I like to think about it like this. So let's start off with an example. You're camping and there's a grizzly bear that's been snooping around your food, and it sees you and it starts to run after you. So we know that this grizzly bear can run about 30 miles an hour, and I want to know how many feet per second this is, because if you have a big grizzly bear running after you, you definitely want to know if you have a shot at outrunning it. So we're going to use a process called dimensional analysis, which I've mentioned before, to do this rate conversion. Dimensional analysis is the process of including units of measurement as factors when you compute. In the last lesson, when I said, hey, units can cross-cancel just like numbers when you're multiplying, that's what we are referring to here. You will use this process a lot in science classes, especially next year in APS. So let's go ahead and let's see, what does it take to change this grizzly bear's rate of 30 miles per hour into feet per second. The first thing you want to do is set it up just like I've done here. I have two rates, two unit rates, in fact, 30 miles per hour, feet per second. And note that these are equal. These are equal values. They're just two different ways to describe the same thing. So, yeah, how many feet per second is this grizzly bear running? Well, the first thing you need to do is write down what you know. We are doing two conversions here. We are changing hours into seconds, and we are changing miles into feet. So I recommend to first write down what you know. You may use the charts given you on your handout to help you in case you don't know a basic fact, or you can use your textbook as well. So what's the basic fact that connects feet and miles? We know that 1 mile is equal to, again, 5,280 feet. So write down that rate. These are rates that we know, which we will be using to help us convert. Then we need to know how to get from hours into seconds. Okay, well, you might need to use a couple of conversions here. We know that there are 60 minutes in an hour, and we know that there are 60 seconds in 1 minute. So if I wanted to know how many seconds were in an hour, I would need to do 60 times 60 to get 3,600 seconds in 1 hour. So those are the basic rates that we know. And again, if you weren't sure about this 3,600, you could easily compute that, 60 times 60. So how do we now use these to convert 30 miles per hour into feet per second? Well, let's start with what we're given. The setup is really, really important. I am going to be looking for this specific setup. So please practice this when you are working through these problems. So we're given 30 miles per hour, and I have two rates that I need to use in order to convert miles to feet and then hours to seconds. So I'm going to use two lines here. I'm going to be multiplying by two rates. Make one red and one pink. So it doesn't matter which rate we start with first. Let's go ahead and convert the miles into feet. So if I have 30 miles in the numerator and I want miles to cancel out, I have to put miles in the denominator. Well, what number's associated with miles? 1. I know that in 1 mile there are 5,280 feet. So that's how I will set up this rate. I want those miles to cancel out. So 1 mile to 5280 feet will be set up in this fashion. And when we multiply 30 by 5,280, we will get that conversion of how many feet there are in 30 miles. So that was our distance. I'll just label that distance. The other piece we need to convert is our time. So let's go ahead and write that here, time. I have 1 hour in the denominator. So again, I want my hours to cancel out and I want to be left with seconds. So how will hours cancel out? They will cancel out if I put hours in the numerator. So 1 hour in the numerator, and let me use the rest of the rate to 3,600 seconds. Okay. And again, in this fashion, hours cancels out with hours. What units will we be left with? Aha, feet per second. And isn't that what we want? To know how many feet per second we're given? Absolutely. Now, I am multiplying all of these rates. It really doesn't matter which I multiply by first, whether it be the time rate or the distance rate, because of the commutative property. But here I've set it up in this fashion, so we'll just go with it. Now, we multiply fractions like we multiply fractions. 30 times 5,280 times 1 will be in the numerator, and 1 times 1 times 3,600 will be in the denominator, and I'm going to include my units here. We need to go ahead and do this calculation, so here's where you are allowed to use a calculator. You could simplify first, absolutely cross off a 0 to make the math easier if you'd like to. Okay. But using a calculator, we will get 158,400 feet per 3,600 seconds. Now we are almost there. This is equal to 30 miles per hour, but I do want a unit rate. I want to know how fast this bear is going per second. So you may need to make one more adjustment here. To get a unit rate, we will divide 158,400 by 3,600, and you will, voila, get 44. Now, keep the units. 44 feet per second. This happened to work out really nicely, but always read your directions. If you need to round to the nearest tenth or hundredth, please do so if necessary. So we just found out that this grizzly bear, if it's traveling at 30 miles an hour, that's equal to a rate of 44 feet every second. So, could you outrun this bear? You'd have to be very fast. Hopefully the bear will just get distracted and run away in the opposite direction that you're going. So there we go. We've just converted a rate. What I would like you to do now is to get out the handout that I gave you in class. I believe it is yellow. And I would like you to try the first example on your own. Actually, I think we just... Oh no, it's a little bit different. Yes, please try this example on your own. 45 miles per hour, and you want to convert it into how many feet per 1 second. Hit pause, come back to this when you're ready to see the process. Okay, so we are converting. We're going to use the same steps that I just showed you. So we start with what we're given, 45 miles per 1 hour, and I need to multiply it by a rate that I know. Well, I know that there are 5,280 feet in 1 mile. So we'll set that up. Again, I want my miles to cancel out. So that's the distance rate, and that's going to convert my miles into feet. Now I want to focus on the time. So let's see, I have 1 hour, and I want to change it into seconds. So I know that in 1 hour there are 3,600 seconds, just like before. When we multiply across, we get 237,600 feet, all over 3,600 seconds. And again, that's because our hours cross-canceled as well, leaving us with just feet and seconds. We do need a unit rate. When we divide, this works out really nicely, as 66 feet per second. And if you stop for a moment, does that make sense? Well, here, if we're traveling faster, in a vehicle at 45 miles an hour as opposed to 30, does it make sense that we're going more feet per second? Absolutely. Let's take a look at the second example together because this one is involving different units. So we have a little bug that is crawling on the ground and it's going 26 centimeters per second. Okay. And I want to know how many meters per minute this happens to be. So this is what I'm trying to find out. I know I have 26 centimeters per second. I want to know how many meters per minute am I going. So let's write down rates that we know. We want to get from centimeters to meters. You should know this, but if you don't, you can use your handout. There are 100 centimeters in 1 meter. Okay, and I want to know how to get from seconds to minutes. So what's the connection between seconds and minutes? There are 60 seconds in 1 minute. Both of these rates will help us to convert. So let's write down what we're given, 26 centimeters per 1 second. And this time let's go ahead and convert the time first because again it doesn't matter which one you multiply by first. So if I'm dealing with my time, okay, I have 1 second down here. So if I want my seconds to cancel out, I need to put seconds in the numerator. And what number is right next to our seconds? 60. That's my rate, 60 seconds per 1 minute. So there's my time. And let's do distance. I have 100 centimeters per meter. So let's see. Here I have centimeters in the numerator, so I want centimeters in the denominator. So 100 centimeters goes in the denominator, and that's per 1 meter. Okay, let me just make sure that everything cancels out correctly. I'm left with meters per minute, and that's what I want. When we multiply across, just using the numbers as is, this is what we get. And when we divide by 100, we can do that in our heads. We can move the decimal left twice. We get 15.6 meters every minute. So this bug can get pretty far. All right, please try example 3 on your own and come back to me when you're ready to see the solution. Okay, so in this case, we have 32 meters per 1 minute, and I want to know how many centimeters this is per hour. So let's just focus on what we already know. I want to go from meters to centimeters, so I can use the same 1 meter equals 100 centimeters from before. That works out pretty nicely. This time I want to convert minutes into hours. So what's the basic fact? 60 minutes is in 1 hour. We will start with 32 meters per minute. I'm going to use my distance rate first, because why not? 1 meter per 100 centimeters. And then I'm going to go ahead and use my time unit, and I have minutes in the denominator, so let me put minutes in the numerator so that those units cancel out. Meters and meters, minutes and minutes. I'm left with centimeters per hour. Voila. Here I already have a unit rate, 1 hour, and you get 192,000 centimeters per hour. Okay. What I'd like you to do now is to go ahead and look at page 17, and we are going to do number 2 together. Not all conversions are as intricate. So here we have giant pandas. They can spend up to 16 hours a day eating bamboo. How fun. We want to know how many minutes per day is this? We can use the same idea. What do we know? Well, we are converting hours into minutes. I know that there are 60 minutes in 1 hour, so let's write that down. And look, we don't even have to convert the denominator because we want to keep days. We just have one rate to multiply by. When we do this math, we get 960 minutes every day. I will see you in class. Thank you.